In ALEKS, there's a topic titled Solving a Word Problem Using a Quadratic Equation with Irrational Roots. Now it looks a little more complicated than it really is. So just take a little time to read through this. It's telling you that when a ball is thrown, its height in feet is h, and after t seconds. So its height, h, after t seconds is given by this equation. So h is the height of the ball at t seconds. V is the initial upwards velocity in feet per second, and it's telling us that the velocity is 27 feet per second. So what you're going to end up doing is replacing V here with 27, and it says to find all the values of t for which h equals 10 feet. So the height is 10 feet. So you're just going to replace h with 10. They want you to not round any intermediate steps and round your answer to 2 decimal places. Okay, so here's a little picture of what's happening. This is the height of the ball over time. So kind of after 1 second or 2 seconds or 3 seconds, you can find the height. Okay, that's the general idea of what's going on here. Okay, so here's your formula. You replace h with 10, goes here, v with 27, and you look and you have a quadratic equation. Now, you know that we want it to be written so that it's equal to 0. I like to have my a value to be positive just in general when I do this, just in case I can factor it. It makes it easier. So I'm going to add 16t squared to both sides, and then subtract 27t from both sides. And that gives me 6t squared minus 27t plus 10 equals 0. All right, and so you could try to factor this. You could see what two numbers multiply to give you 160, but add to give you negative 27. But when I have some really large numbers like that, I might see if I can find something quickly, or I might just jump in and use the quadratic formula. This one, they told us there were going to be irrational roots, so you know you're going to need to use the quadratic formula. All right, so you take your a value, that's going to be 16, b is negative 27, and c is 10. And we plug that into your quadratic formula. So you need to have this. Put this down in your notes and keep this someplace handy so you can reference it, maybe the back of your notebook. So this is opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And if you've made it this far, you've already practiced with this formula. So I'm not going to go over that too much in this video. So here we can see we're taking the opposite of a negative 27, so that's going to give us a positive 27. And then when we take the negative 27 and square it, subtract 4 times 16 times 10, that gives you the square root of 89. Okay, and then this will give us a 2 times 16 or 32 in the denominator. Now at this point, then we're going to separate these into our two problems, one with the minus and one with the plus, and plug these into our calculator. So really the big request that I got on this was to kind of see how the calculator works. And so what we're going to do is remember that when you have this is all divided by 32, that's like having a big parentheses around this numerator. So I'm going to say parenthesis 27 minus, and then I use square root, so you're just putting it in like it reads. You just need to make sure you either put parentheses, so I want to undo that one. I've got to click out so my parentheses on the outside of the square root. And then I can just divide this by 32 and press equals. And you can see this gives me my x, one of my solutions for the time, and it asks us to round it to the nearest 2 decimal places. And so that means we're looking at this 4. We've got to decide if it stays a 4, becomes a 5, and we look at the digit next to it, which is an 8. If the digit next to it is 5 or bigger, remember we round up. So this becomes 0.55 seconds. Okay, and then you repeat that process with the 27 plus the square root of 89 over 32. Now I'm just going to show you this. If I didn't use parentheses, you also could have said 27 plus the square root of 89, and then push equals, and then divide that result by 32. Okay, and so this gives me my other value. You can see it's the same as what they have there. And nearest two decimal places, so I'm looking at the 3. Does it stay a 3 or become a 4? We look to the right, and that number to the right is bigger than 5, so this becomes 1.14. Okay, now I'd be happy to work through this whole problem all the way through, but I kind of have a feeling that if you've reached this point, you're comfortable. If I'm wrong on that, just let me know, and I can create another video where I'm working through this whole quadratic formula and everything else.